All right, today we're looking at 8.4 trigonometry, sine, cosine, and tangent functions. These are trigonometric ratios. So they're ratios of two sides of usually a triangle. And so the first of them is the sine. The symbol here next to sine is theta. And the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of some angle theta is the opposite over the adjacent. Now, most of the times you will see this as a specific, it's called a mnemonic device, a way to remember. That mnemonic device is, I don't want to put it there, is so toa. So katoa will be coming in more and more handy as we go. The SOH goes with the sine. It's the sine, the opposite over the hypotenuse. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. So cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. All right, so our question might be, how do these actually fit into our triangle? And the answer to that to start with is, first of all, we're starting with a right triangle. So if we have a right triangle, and let's call this triangle A, B, C. The side opposite, that is across from angle A, is side A. The side that's across from angle B is side B. And across the right angle, which is called the hypotenuse, is side C. Right? This should be familiar, as a squared plus b squared equals c squared in a right triangle is the Pythagorean theorem. And we also had other theorems that deal with those three variables as well. So if we switch over and look at a specific angle here, like the sine of angle A, the sine of angle A is the opposite over the hypotenuse. These are sides. The side opposite angle A is side A. Over the adjacent, you might ask yourself, well, aren't B and C both adjacent? And the answer, over the hypotenuse, which can only be C. Right, we'll get back to adjacent here on the next one. The cosine of A, this is the adjacent over the hypotenuse, right? Ca, C-A-H, right? So the cosine of an angle is the adjacent. So which is the adjacent side? Is it B or is it C? Remember, adjacent means next to or makes it up, right? So B and C both make up angle A. However, C is always going to be called here the hypotenuse. So we are not going to call it the adjacent. So we're going to call B the adjacent. And again, C is the hypotenuse. And then we have the tangent of A, which is the opposite. The opposite side for angle A is A, and the adjacent is B. Okay. We can do the same thing for B. So the sine of angle B is, sine is opposite over hypotenuse. The side opposite angle B is side B over the hypotenuse is C. The cosine of B, this is the adjacent. Again, A and C make up angle B, but C is the hypotenuse. So A is the adjacent side. And then the tangent of B is the opposite, which is B, over the adjacent to B, which is A. Now, something you should notice here is that the sine of A is A over C. The cosine of B is also A over C. So the sine of A and the cosine of B are equal to each other. The cosine of A is B over C. The sine of B is B over C. They are equal as well, right? And then you'll notice that tangent of A and tangent of B are not equal to each other, but they do have a relationship there, right? With that, recognize that because we are in a right triangle, triangle ABC, and C is a right angle, A and B must have a few things that are true. We've talked about this a lot. So one of the things that must be true is that since C is 90 and the three angles sum to 180, A and B must sum to 90, right? Because the three angles are 180, we know 90 of them are at C, so the other two sum to 90. That does mean that both A and B are acute angles, which then plays into these statements down here. All right. Moving forward, we're going to look at some examples for these. So if we have a triangle, it's a right triangle, SRT, and say that we knew the sides were 16, 30, and 34. What would be the sine of angle R? So again, I'm going to say it again. Remember, so katoa, so SOH, right? The sine of an angle is the opposite over the hypotenuse. The opposite side to angle R is 16. The hypotenuse is 34. We might simplify that. Both 16 and 34 have a common factor of 2. And so we get 8/17. As a decimal is about 0.47. Oftentimes it's going to ask to the hundredth, so that's 2 places after the decimal place, right? How about the cosine of R? So the cosine of R, co goes with the ka, C-A-H. Cosine of an angle is the adjacent over the hypotenuse. The adjacent to R is 30 over the hypotenuse 34. They also have a common factor of 2. So we get 15/17, which is about 0.88. I don't make my 8s like that. And then the last one for r, we have the tangent of r. Tangent goes with TOA, TOA, T-O-A. So the tangent of an angle is the opposite over the adjacent. Opposite to r is 16, and the adjacent is 30. That is 8 over 15. It's about 0.53. All right, what I want you to take a minute to do here is to look at the sine of s, the cosine of s, and the tangent of s. All right, and I want you to pause your video to do that. And once you think that you have it, come back and take a look at it. So sine of s is opposite, which is 30, over the hypotenuse, 34. We did this one already. That's 15 over 17, about 0.88. The same as the cosine of r, right? The cosine of s is the adjacent 16 over 34. That's 8 over 17, or about 0.47. And then the tangent of s is the opposite 30 over the adjacent 16. And about 15, not about, it is 15/8. And 15/8 is about 1.88. Now don't get confused here. You do it in your calculator, you should do it in your calculator. You'll get 1.875. Because we're rounding to the 100th, we'll still round it up to the 100th, even though it ends after the next digit. All right, we have 1.88 there. A few things that you should notice here. The first ones here, not always gonna be the first ones, but the sine and the cosine for what we're working with are always going to be less than 1, right? 0.88, 0.47, 0.88, 0.47, right? Those are always less than 1. For the tangent, it's always going to be 1, one of them will always be 1 or less, one of them will always be 1 or greater. Another thing for now, as we're working, the ratio here will always be positive because we're looking at sides of a triangle, and the sides of the triangle are always positive. Okay, we're going to look at one more. So same triangle. RST. R is 10. S is 24. And T is 26. So here you should pause the video. You should work it out exactly the way we just did. So finding, we'll just do the R's. So do sine of R, cosine of R, tangent of R. We won't do the sine of S, cosine of S, and tangent of S unless you really want to. I'll do them all when we come back. But all I want you to do is the sine of R. All right, so again, pause the video if you haven't, work on them, and come back. You should be able to check your work here. All right, so sine of R, opposite, the side opposite of R is 10 over 26. That's 5/13, which is about 0.38. the cosine of r is 24 over 26, which is 12/13. 12/13 is about 0.92. And the tangent of r is the opposite 10 over the adjacent. It's 24. Which is 5/12, about 0.42. So again, those are the ones we had to do. You have the sine of s, which is the same as the cosine of r. So that's 12 over 13, about 0.92. You have the cosine of s, which is the same as the sine of r. That's 5 over 13, about 0.38. And you have the tangent of s. The tangent of s is 24 over 10, which is exactly 2.4. Oops, did we get it off the page there? Sorry about that, I ran off the page. All right, in the first part of the chapter here, we talked about special right triangles. They are 30, 60, 90s and 45, 45, 90s. They are special because it only takes one part to solve them. So if we know one part of a 30, 60, 90, one side, we can solve the other sides fairly easily. And if we know one side of a 45, 45, 90, we can find the rest. All right, so what we're going to use is trying to make this connection here. So we want to find the sine of 30 degrees. So again, on the last part we were doing, we were just saying the sine of some angle is this ratio, right? We're going the other way now. The sine of some angle 30, so the sine of 30 degrees has to be some ratio. And it's always going to be the same, no matter how big the triangle is, because they're similar triangles and it works that way. So let's take a look at a 30, 60, 90 triangle. As a reminder, across from the 30-degree angle over here is the shortest side. Across from the smallest angle is the shortest side. And again, the hypotenuse across from the 90-degree angle is always the longest side. So across from the shortest side, we might have a measure of 1. I'm making this up. I'm making what I think is the simplest special 30, 60, 90 triangle. So if the side opposite the 30-degree angle is 1, the hypotenuse has to be twice that, which is 2. And to go from the short leg to the long leg, we multiply by √3 and we get √3. So this is what I would consider to be the simplest 30, 60, 90 with a short leg of 1, hypotenuse of 2, long leg of √3. Right? So the sine of 30 degrees, the sine of this angle, sine is SOH, S-O-H, sine of 30 is the opposite over the hypotenuse, right? Again, sine, so that's the sine is the opposite, off the page again, opposite over the hypotenuse, right? So the opposite of 30 is 1, and the hypotenuse is 2. The sine of 30 is 1/2. What I would do if I were you is, hopefully you have a calculator since it's required for this class. to check the sine of 30 in your calculator. All right. If you do not get 1/2, that means your calculator is not in degrees, and you need to fix that. So the sine of 30 is always 1/2. If it comes up to, I think it's something like 0.9 repeating or something weird, 9.8 or 9.9, something like that. Your calculator is in something else called radians, and you need to change it to degrees. If you don't know how to do that, I can help you, but you would need to talk to me about that. All right. If you're using an online calculator, I don't recommend, but there's usually a button you can press to just get it flipped over. All right. The tangent of 45 degrees. So this is a 30, 60, 90 triangle. We don't have a 45-degree angle in there. But if we switch over to this, we're going to make the simplest 45, 45, 90 triangle we can get, which is sides of 1, hypotenuse of the square root of 2. The tangent of either of these two angles is going to be the same. The opposite over the adjacent, right? Again, TOA, SOHCAHTOA TOA is tangent equals the opposite over adjacent. The opposite and the adjacent are both 1. So the tangent of 45 is 1. Okay, cosine of 60 degrees. This is back to our 30, 60, 90. The cosine is the adjacent over the hypotenuse, and it is 1/2, just like the sine of 30 was 1/2, and we already talked about how that works, right? I think we will end there for today. I'm not going to put the homework here. It will just be posted on Canvas for you, because usually I go a little bit further, but I want to cut us a little short, trying not to fit so much in for a single day. So again, a few reminders, things that are important. This is the most important thing for the day. That is SOHCAHTOA TOA. We use it for the next, I don't know, 4 to 5 days, probably into next week at least. Again, this is sine of an angle is the opposite over hypotenuse. So again, sine, opposite, hypotenuse. This is the cosine of some angle is the adjacent over hypotenuse. And the tangent of some angle is the opposite over the adjacent. A few other things to note, though with us not being in person as much, you may not find this to be nearly as necessary. It is pronounced sine because it's spelled sine. S-I-N looks like sin, so it looks like the sin of an angle. However, it is just to shorten it so that it's easier to write. I know shortening by one letter may not seem like a big deal, but when the second one is the cosine, right, it is not cos or cos, it is cosine. So even when it's written here, we say the cosine of theta, not the cos of theta, right? And then tangent, again, it's not tan theta, it's tangent. And like I said, I think we're going to end there. If you have questions, make sure that you do ask them.